think we'll go ahead and get started. First, thanks for taking time out of your day and your lunchtime schedule in particular to stop in and let me share a little bit about mobile and digital health with you. On behalf of the courts, which in case anybody doesn't know is the Adult and Child Consortium for Health Outcomes Research and Delivery Science here on campus. We work with the School of Medicine and we work with children and helping to support investigators in doing excellent health outcomes research. My name is Susan Moore. I am the director of the Mobile Health Research Core at Courts. I'm also an assistant professor of medicine in the School of Medicine, and I exist in the Colorado School of Public Health as well in the Department of Biostatistics and Informatics. When I'm not doing that, I'm over at Denver Health, working about half of the time as the associate director of research operations. Before I did all of that, I worked for about a decade in information technology industry, doing knowledge management, mobile device support, information exchange from mobile to non-mobile settings, things along those lines, and that is what brought me to focus on mobile and digital health research today. To give a broad overview of what we're going to do today. What we're not going to do, I am not going to answer the A to Z exactly how one does mobile and digital health research. There's too much. But what I will do is give you an overview of some of the key considerations, the core elements that you need to be aware of, things that you need to think about when you're doing work in this space, or if you're interested in getting started in doing work in this space, and give you an idea of some of the different areas that you might need more information in, and places that you can go to find resources to help you with that. So I'm going to give an overview today. We're going to talk a little bit about effective principles for mobile and digital health research, how to collaborate and consider collaboration outside of the walls of an academic-only setting, and really essential considerations for project success. We'll go over some of the common pitfalls and how to avoid them. We're also going to do a little bit of orientation definitionally, because some of the concepts that we're going to be talking about here today, there's a lot of semantics in the room and a lot of things that are referred to in different ways. So let's get on the same page first. And the first thing to do is distinguish in between health IT and health informatics. How many people in the room, for anybody who's on the Zoom, I can't see if you raise your hand, but feel free to go ahead as well. How many people in the room are familiar with or have worked with health IT, health information technology? Okay, we have a few. How many have heard of or are familiar with the concept of health informatics? We have a few of that as well. The key difference in between the two is that you can think of the IT, the information technology, as being the tool that you use to get something done. Health informatics is the science of how you do it. The two work together very commonly, but they're not exactly the same thing. When you're writing your grants and distinguishing between the key elements in the projects that you're proposing, that's an essential consideration, because there are some federal funding agencies out there and some other funding groups out there that are interested in the one but not the other, and they will notice if you conflate the two. So that's one thing to think of definitionally. I've referred to mobile and digital health as I started the introduction here, and the reason for that is that these terms are beginning to be used more interchangeably. So to understand that, we have to look at what is digital health exactly. The broad scope of digital health as it's currently being considered, and including by the FDA, includes mobile health, but it also touches on health IT, it touches on wearable devices, which are also very tightly tied to mobile health, telehealth and telemedicine, and also personalized medicine. The more traditional version of mobile health, or mHealth, is more narrowly focused on the use of mobile and wireless devices, specifically mobile devices, to improve health outcomes, healthcare services, health research, use of health. Mobile and wireless devices can be, sensor-based things. They can be something that's specific to a health purpose, and they can be your phone. They can be anything that you can hold in your hand. It can be an app on your phone. It can be the phone itself. It can be text messaging. It's a very, very broad scope of potential here. But it also has the possibility to reach a very broad population in the world. Over 85% of the global population is using some sort of mobile technology. There are over 5 billion mobile accounts worldwide. That's a lot of people. That's a lot of reach. That's a lot of potential. So thinking about some of the broad spheres or the broad areas in which mobile and digital health have application or have some sort of influence, it's most focused on the use of the data, the use of mobile and wireless devices, the use of sensor technology. We're all familiar with that, oxygen readers on the fingers, blood pressure cuffs, things like that. The use of mobile applications. This can be something most commonly recognized as an app on the phone, but can also be used and embedded in other technology and techniques as well. And the use of communications sent back and forth without having to be connected to some sort of physical mainframe or wired technology. I mentioned that 85% of the world's population, it's a big market. It's one of the fastest growing markets in healthcare out there. Almost a 50% compound annual growth rate over time, market value of up to close to 60 billion, within the next couple of years. And then looking at just a subset of that market, looking at the app market alone to get a sense of how quickly this growth is happening. In 2010, looking at apps on your phones and on your smart devices, about 85 million, just under 100 million. Now, as of 2015, almost up to 500 million, and in 2018, I believe we're over 600 million, almost 700 million and rising. So a lot of opportunity here and a lot of potential benefit to patients and health systems. There's also a lot of people doing a lot of work in this space. One of the most common things that I hear when people tell me, I'm interested in doing mobile health research because I have an idea for an app, one of the first things that I ask them is, have you looked to see if somebody else has already had that idea? We've all heard the saying, there's an app for that. It's probably true. It doesn't necessarily mean it's always the best solution out there, but there are a lot of solutions out there. So Google Play here, so these are your Android devices on the far left, followed by the Apple Store, iOS, and then way over at the other side, the very persistent BlackBerry, which refuses to die. But all told, we're looking at, and again, this is just a segment of the market. This is just a segment of the possibilities. We're looking at over 5 million apps that are currently available and growing faster than the rest of the market. But overall growth is finally slowing. Things are beginning to stabilize. Things are even beginning to stabilize in the app market itself. So we're looking at 9% growth in apps overall in 2017 versus a faster pace in 2016. But what that translates into when you're thinking about how am I going to engage with patients, how am I going to connect with people, that's 5 hours a day of people staring at these little screens. That's a lot of focus in a very small space. That's an unparalleled opportunity to get information, to get communication, to have some sort of engagement with people by being aware of the possibilities in this regard. Again, looking at I'm not going to spend a lot more time on this, but looking at sort of the year-over-year growth, showing that where things are of interest. There's a lot in the idea of fitness content, weight loss, and nutrition. And not so much looking at medicine and general health. Does anybody know why that is? Anybody have an idea why that might be? Yes. Very good point. So for the people on the Zoom, the question is, does it have to do with personal information, and does it have to do with the accuracy of the information available? Both of those are absolutely key. We'll talk a little bit about HIPAA regulation and how that affects the ability to do this. FDA regulation also is a factor when you're looking at things that involve medical advice and medical devices. But when you're looking at fitness and general wellness, those are not regulated the same way. So a lot of the work that has been done and is being done is in those spaces, which is great if you're working in those spaces. If you're not and you're more interested in medical and general health, what that means is there's an area of significant opportunity. And there are things that you have to be aware of, but there is a lot of opportunity and potential here as well. App loyalty by type. This is just how many people have downloaded an app on their phone or tried something and then opened it a second time? How many people are used to, I'll give this a look and maybe it's not interesting and I'll just delete that? I see a lot more head nods. You're not alone. That is the most common experience. In fact, the median number of times that people open an app is 1. So that's why I'm showing these, because it matters. The design of your solution matters, and the ongoing engagement in order to have that loyalty, that continuing interaction with mobile and digital health solutions, if that's the area in which you want to focus your research, it's important to think about these things up front, to recognize that people have very short attention spans when it comes to mobile and digital technology. Pace of development is also something to really keep in mind when you're working in this part of the field. I think we're all familiar with the National Academies of Medicine and the research finding that it takes about 17 years to translate just 30% of clinical results into clinical practice. That's the ones that make it out the gate and get into practice. That's a very long period of time. If you went to any tech developer and said, we're going to do this and it's going to take us 17 years to do it, they would laugh you out of the room. Their business models don't allow for it. The pace of technology development doesn't allow for it. Back in, I believe it was early 1960s, Gordon Moore, no relation, who worked for Intel Corporation, came up with something that's called Moore's Law. And what that refers to is processing power on the computer chips, basically. And what he discerned was that about every 2 years, overall computer processing power doubles. And as that happens, things get smaller, things get faster. Every 2 years since the 1960s, still proving true, still hasn't been broken. So, which means that the pace of development in technology needs to be pinned very close to that 2-year period. That leaves a 15-year gap in between traditional research timeframes and mobile and digital health that we as investigators have to figure out how to close. It's also important when you're thinking about doing work in this space to realize that because of that 15-year gap, there's a fairly significant evidence gap as well for solutions that are out there. When I first was looking at these numbers and putting this together in late 2016, at that point, only 113 out of those 5 million apps had been rigorously tested to see if they actually did the thing that they claimed they were doing. 113. That's not that many. There's a lot of work to be done in the field of mobile and digital health research. Over half of the things that are out there have fairly limited functionality. Most of them just present information and don't engage in other ways. It might contribute to that median number of times things are being used being 1, because people are interested in things that do more than that. And while connectivity and social media are very popular, it's more challenging to connect solutions, whatever they may be, to the electronic health record, to electronic medical, to clinical systems, and to the healthcare system. So these are challenges that need to be overcome, or at least need to be understood when you're proposing to do this kind of work. It's even more important in healthcare because healthcare is complex. Healthcare is incredibly complicated. This is not news to anybody in this room, anybody on the Zoom call. When you're making changes in a complex adaptive system like healthcare, you make a change in one area and you have unexpected consequences in another. Actions have outcomes. Outcomes have results, sometimes good. Sometimes those unintended are not so good and can be disruptive or problematic. And so before people put something clinical practice, before they make it part of the day-to-day, they want to know if it works. And they want to know if it works well, if they can depend on it, and if it's something that their patients can depend on as well. Otherwise, many things that may be incredibly promising are not going to get out the gate. They're not going to be adopted. For clinicians in the room, how often are you asked to do something else in your administrative time in taking care of patients? How frequently is there something else that needs to be added to your routine? Is that, would you say, a common thing, or that almost never happens? Common? Yeah. Being asked to try mobile solution after mobile solution and add thing after thing after thing without some evidence of it being effective? Generally, people don't like doing that. And so that's important to consider when you, as an investigator in this area, wants to engage people in trying your products, trying your solutions, and making these changes. It can be harder sometimes in this field than with other areas of health outcomes research, because you're asking them to use an actual thing rather than maybe just make a change to a practice. You're asking them to do two things together. So that brings me to the point where you have an idea, you want to do this kind of work. What comes next? The most important thing to figure out before you go forward from here is, are you testing a research question that happens to involve the use of technology as a way to do something? Or are you testing the technology, the mobile and digital health product itself? And the reason that I'm making such a clear distinction there is that it is very common for investigators to like to do one or the other, but not both. And the long-term trajectory for what to do with mobile and digital health solutions and mobile and digital health research looks very different based on those two things. If you're interested in building a solution, whatever that might look like, or working with a company to build a solution, or working with others to build something new because there's nothing out there that does what you want it to do, and you're interested in building it and having it adopted and carried forward and using it and being used and integrated into the system, that's fabulous, that's wonderful. But that's a very different trajectory with a very different set of things to consider than if you have a healthcare or health delivery problem that you want to solve and you think technology might be able to help with that, but you're not interested in building and designing and developing the technology itself. So, and we'll talk a little bit more about this as we go through. But I'm bringing it up early because it is so critical. And there is no wrong answer. There is no one right way here. But it's important for you yourself to figure out which of those things you're more interested in. Or if you're one of those people that likes both, both is great. But it's important to know. So you have an idea, you have something that you want to do, and one of the next things that you need to think about is, what does a good team for a mobile and digital health research project look like? Who needs to be in the room? Who needs to be involved with that? These projects are inherently multidisciplinary. They're very interdisciplinary as well. You have people with a lot of very particular expertise, and some of it that doesn't overlap as well, that you need to bring together into a room and have people interact and share that expertise and work back and forth. You may have computer programmers who have no clue about clinical practice. You may have clinicians who just want to press a button and it does the thing, but don't know how to articulate how to get that there. And having these conversations and this dialogue back and forth is absolutely essential. Multidisciplinary is absolutely essential in this kind of work. Thinking about the design. When you say the word design in a mobile and digital health context, depending on who you're talking to, people are going to hear different things. Research investigators are going to be thinking very naturally about study designs, about methods, about hypotheses, about protocols. Industry designers or tech designers are going to be thinking about, what does it look like? How does it work? What is installed on? So very, very different things, very essential to have both of those working together. So you need to think about both the design of the study and you need to think about the design of the solution or the product that you'll be using to do it. You need to think about data considerations. Who owns the data? Is it the health system that you're working in? Is it the patient? Is it the company that makes the product? Is it you as a researcher or research team? There, again, no wrong answer, no single one right answer, but something that's incredibly important to think about up front before you get to the other side of the project and find out that different core people or different groups that are involved in the work have had different expectations for that outcome. And then finally, something near and dear to every researcher's heart is the funding. You need to think about funding not only for current, not only to get the initial project off the ground, but how to sustain it and how to go forward and what that future funding looks like. And we'll talk about that a little bit. So, thinking about your research team members, thinking about that multidisciplinary approach, you need somebody with clinical subject matter expertise for whatever health outcomes problem that you're choosing to address. Depending on if you're using an existing product or not, most of the time you're going to need somebody who has some sort of software or hardware development experience. You're going to need a programmer, a coder. You're going to need somebody who has expertise in UX UI, which stands for user experience and user interface design. And that's important because, as a comparison, let's say, how many people in the room use Facebook? How many people in the room might say that they find Facebook easier to use than Epic? Exactly. The difference in the two is that one company is focused absolutely on making a product that engages its client to use it and continue to use it. And the other one is focused on doing a lot of very important things for delivering health information and managing health information. And the ability to interact with it well came secondary. No offense to Epic, they're a great product, but they didn't start out thinking about user interface design as their primary focus. You're going to need somebody who's focused on health informatics, or the technology itself, looking at data collection, data exchange, how the mobile product might connect to different systems if that's desired. And I highly, highly recommend that for anything that's going to be implemented in a healthcare setting, that you have an implementation science expert on your team. You have somebody who is used to figuring out what happens when you try to bring something from concept into practice and it runs into the real world. These are the people who are used to thinking about those and to looking at how to adapt study designs or adapt responses based on what happens when you run into real world problems, and that happens a lot with technology. It never, never finishes exactly as you intend it to start. I'm not going to spend a lot of time doing Research 101, Study Designs 101, but I'm putting this up here to show the difference in between research quality improvement and program evaluation, because potentially all of those domains can be appropriate for mobile and digital health work. You're in this room because you're interested in the research aspect of it, and we're going to focus mostly on that, but I wanted to point this out because you can do very good work using existing technologies to improve a practice or quality improvement practice, to test something new, to try shifting a delivery. You can publish on those things. And if you're looking at using a technology solution to improve a specific program, that's possible as well. That's something that you can evaluate in a rigorous fashion as well. So I want to make sure that we at least touch on that here in this room, because it doesn't, I am a researcher. Research speaks to the core of my soul, but it doesn't always have to be research when it comes to mobile and digital health. So just important to consider that. But depending on the stage where you are, and depending on what you're trying to do with the technology, there are three large domains that you can, and three types of questions that you can answer when it comes to mobile and digital health in a research setting. One is, can you do it at all? Is it even possible? These are proof of concept studies. These are pilot studies. These are feasibility studies. These are your early stage work. Then, once you've demonstrated that you can do it, it is technically feasible to accomplish the thing that you're trying to do. The next question is, does it work? This is the question that only 113 of those app developers have answered so far in a rigorous way. Does it work? Is it effective? This is where a randomized controlled trial might come in. This is where looking at different types of efficacy studies might come in. And then finally, once you have something that you have an evidence base for, the next question is, will it last? And that's where you want to start thinking about pragmatic trials, implementation science, observational designs, integration strategies, going from the initial studies, initial RCTs into something that's larger across multiple sites, multiple systems. I mentioned earlier the idea of, do you want to be a developer? Do you want to build new solutions, or do you want to test existing ones? And so if you're thinking about selecting a solution, you're going to want to think about your intended user base. So when I say that, I mean, who do you actually expect to use the technology for some purpose? Is it something that you want in the hands of patients? Is it something that you want in the hands of clinicians, health professionals, the care team? You want to think about the UX, UI, the interface and the experience in using it. And you want to think about the critical question of choose something that's already out there or build something new if there's nothing out there that fits your needs, or if there's some reason that you think that you can do better than what's already out there. Very often you can. Some of the stuff that's out there, a lot of the stuff that's out there doesn't have a researcher's lens, doesn't have a clinician's lens in the same way. And so there is a lot of opportunity. You need to consider solution fit. You need to consider costs involved. And when I'm talking about that, knowing your audience, knowing your intended users, there are some theoretical considerations, theoretical underpinnings that can help you think about and make some of those decisions. I'm going to just put 3 up here just very quickly because otherwise we could be here all day, and I do want you to be able to get back out of this room on time. So the first one of those is looking at diffusion of innovations theory, which started with agriculture and has been determined to be one of the best theories when it comes to looking at technology adoption and adaptation across population groups and strata. So you want to consider your demographics, the technology profiles of your users. Are they high-tech? Are they low-tech? I'm presuming that a lot of the people in this room have had experience in helping their parents reprogram remote controls or their phones, or yes, many nods, exactly. You want to think about those things before you're proposing that somebody use a particular type of tech, and you want to think about where they fall on this spectrum. The innovators and early adopters, these are the people who stand in line outside the Apple Store when a new device is announced and queue up around the block. Over here at the other end, these laggards, these are the people who are talking about, you can pry my phone or you can pry my technology from my cold, dead hands because as long as it works, why would I ever need to do anything different? And in between is most of the rest of us. You also want to think about simplicity when it comes to tech use. Most of us inherently, it's human nature, are lazy. We don't like to work harder than we have to get something important done. So if you have a choice between a technology solution that requires 15 clicks and log in 5 times at different stages, and one that you touch a button on a screen, which one are you more likely to use? Yeah, exactly. And then thinking about, spinning off of that, thinking about other aspects that go into usability of a technical solution of mobile and digital health. Thinking about, is it effective? Does it get the job done that people are wanting it to do? Is it efficient at doing that job? Is it satisfying to use it in some way? Is there a sense of accomplishment or a sense that I have achieved the thing that needed to happen? Is it easy to learn and easy to remember, or is it something that you have to reteach yourself every time you go back to it because it's very, very complicated on where and how to do different things? Does it work well, or does it give you lots of error screens and bugs? A lot of the stuff that gets put out there in early iterations has problems. People notice them. And finally, the last thing in this particular model, the PACMAD usability model, is cognitive load. And that goes along with that idea of cognitive burden. How difficult and complicated, how much do you have to remember or consider to do in order to use the solution that you're proposing to use? All of these things are important considerations in doing mobile and digital health research, because if you pick something that's very bad at all of these, you're not going to get very far, and it has nothing to do with whether or not the purpose of the solution was good or not. Funding and sustainability. One of the most common questions I get asked is, how much does it cost to build an app? My answer always, unfortunately, has to be that depends, because I have been involved with projects that have cost as little as $3,000 and as much as $300,000, depending on the complexity of the solution and all of the different types of things that people want to do with it. The good news for everybody who looks just really, really panicked here right now is that the $300,000 is much, much rarer than things on this end of the line. You can get something done, especially something done at early stages, for under 6 figures, but the more complicated the solution that you want to build and develop, the more expensive it gets. So you need to take that into account when you're thinking about funding and the scope of the work that you want to do. I want to think about that good design generally involves an iterative process. If you There are a couple of methods in development traditionally called, one is called waterfall development and one is called agile. Waterfall is where you start at the top, you have a plan, you have an idea, you have a development scheme and all of the steps, and you go from top to bottom like the water does, and you come out with a product at the other end. This is great, but you have no chance to adapt anything in the middle. There's no chance to respond to any changes that you might find, shifts along the way in your studying. So that's something to keep in mind. Agile development is the process of going in small sprints or development cycles, maybe about every 2 to 3 weeks, and then checking back. Okay, do we need to change the design? Here's where we are. Here's what we've run into. Do we need to make an adaptation? Do we need to shift? It can take a little bit longer to do that iterative process, but when you get to the end, you've been involved step by step along the whole way. You also want to think about tech support for the product. Is it going to be you and your research team who are answering questions about how to use the mobile and digital health solution for your research participants, or is it going to be a vendor company, whoever built it, something along those lines, who's providing that kind of support? And then again, are you funding the solution? Are you funding the thing that you're building? Or are you funding the research that you're doing with the solution? Key distinction, and one that's going to make a huge difference when it comes to how you approach potential funders and how you frame your applications to them. So thinking about that, let's talk a little bit about funding sources, because there's a lot of different funding sources out there, and some of it is what you might call non-traditional for what researchers are used to. I think all of us are very familiar with federal funding, with the R-series grants, with Ks, with T's, with all of the different alphabet soup of letters that come with federal funding and come with grant awards. We're also familiar to some degree with foundation funding, potentially society funding. But I have some letters up here that people are maybe less familiar with. A lot of developers, a lot of industry partners, when they think about funding, they're thinking about private investment. They're thinking about venture capitalists. They're thinking about angel investors. The difference in the two is that the angels are so called because they will just give you the money because they believe in what you're doing. That's really great. If you can find one of them, good luck. Venture capitalists they believe in what you're doing, but they want a share of the profits. So they take shares in your company or shares in the product that you're developing in returning for staking an initial investment. Seed capital is that concept of the initial investment. Series A, B, and C are different different releases or different waves and stages of development. So each of them comes with releasing a certain amount of stock options, or saying this is where we are, this is how far we've gotten, this is the number of shares we'll sell in order to achieve this type of funding. It's very for people who are interested in going that route and learning more about that sort of industry type of funding, please feel free to talk to me after, or I will direct you to some other resources as well to navigate those waters, because they're beyond the scope of an introductory seminar to describe. Foundation, society, innovation initiatives. I'm bringing this up in particular because it's an untapped well. And a lot of groups out there are interested in dipping their toes into the water of mobile and digital health. There's an investigator with Accords who has received funding from a liver health society to specifically build an innovative mobile health solution. That, that's not the sort of thing that people often come to me and say, oh, I have this idea, I'm going to go out and talk to this specialty group in my field. But it can be very successful, especially as specialty health groups and specialty foundations are getting more and more interested in this area, but they don't know how to do it themselves, and they don't want to. They want to fund bright minds to do it instead. SBIR and STTR. These are federal initiatives that come through the NIH, which must set aside a certain percentage, as dictated by Congress each year, out of the all of the grant monies that they award, for small business innovation research and also small business research, but more focused on technology transfer research. The big difference in the two of these from an investigator perspective within an academic setting is that the SBIR, the principal investigator must be employed by a small company. So you cannot, for example, work for Children's Hospital or the University of Colorado and be the PI on an SBIR grant, because you have to work for this other company more than 50% of the time. You can do that on an STTR, which the award still goes to a small partner company, but that small company works with an academic partner, and the PI can be at the academic organization. And these are grants that are specifically designed to fund development of business and development of technology initiatives with an idea that they're moving towards commercialization, that they're moving towards something that can be a product and market down the line. So these are good ways to get something off the ground if you're building it yourself, and you're finding that a lot of the NIH research initiatives around how to do the actual research study and look at the actual outcomes research are less interested in funding the development of a technology solution to do so. To be perfectly frank, they've gotten burned a lot over the last couple of decades. People coming in with technology ideas, getting partway there, or building just enough of it, and then abandoning it, or not being interested in continuing, or not wanting to commercialize, things along those lines. So now the trend is more to, if you're building something new, to fund the building and the development through innovation and commercialization initiatives, and to fund the research, the use of the product for a research question through the more traditional ways. And that's important to think about when you're looking at what work you're trying to do, what you want to do, how to consider how to fund it. And then the last thing that I have here is challenges and codathons. And that's a process that came from industry, which is the idea that they would put up prize money and people would essentially lock themselves in a room for 3 hours to a week or something along those lines and develop a concept or initial proof of concept product. And then the ones who did it best would walk away with anywhere between $10,000 and $150,000. This is something that Health and Human Services and AHRQ have picked up as, hey, that seems to work for industry, let's try it too. So this is a picture from an opioid symposium and codathon that was held in late December. Agency for Healthcare Research and Quality is doing one right now that they should be finalizing this month and announcing in the spring, focused on patient-reported outcomes. So there are some of these non-traditional mechanisms for funding out there as well. You want to think about, when you're putting your grant budgets together, you want to think about not only what it would take to build it initially, but what the cost of continuance might look like. The servers on which the product sits, the cost of maintenance and upgrades, whether or not it's something that you want to commercialize or whether it's something that you want to just use in a study for a point of time. And if you're partnering with the vendor, how likely is it that the vendor is going to be around at the end of your study? I've unfortunately seen situations where people have partnered with very promising small businesses that didn't have good cash flow or they were doing the traditional model of, I'm going to work in the garage until I hit the magic button and everything works well. Well, sometimes it doesn't. And the company went out of business and left the research team going, what about the rest of my grant? So these are things to think about when you're thinking about partnerships potentially. I feel the need to put this up here, the I-Core training program through CCTSI for groups that are that have something or interested in developing something to take to commercialization. This is an educational initiative that's free and available to people here through the University of Colorado. It was originally sponsored by the National Science Foundation and now is also being sponsored through the National Institutes of Health, and it's a short course for a team of innovators that are interested in taking things to the next step. So, I mentioned looking at new or used. Are you building it yourself or are you looking for something? Basically, the things to consider here is if you're building something new, you can tailor it specifically to your needs, to your study. You own or your team owns, or if you're doing work for hire through the university, you own a share of intellectual property. You have to consider platform design, infrastructure. You have to consider the multidisciplinary team who's going to actually do the building or who's going to actually program it for you. And again, that focus of the study, are you testing the solution or are you testing the use of the solution? So you want to think about how long will it take to build something versus how long will it take to conduct the health outcomes study, the trial that you're interested in doing. Selecting something that's already out there might not be an exact fit for the study or needs, one of the things that's important is that it already exists, so you don't have the same level of that development time and in that process along the way. You need to consider licensing for the use of a product if you're going to go with something off the market. You need to consider the support in working with the company or the vendor that you choose. There's a limited evidence base out there for a lot of existing options. Sometimes that offers the potential because a lot of times innovators and digital health companies are really interested in finding out whether there's evidence base for their product. So they are often interested in partnering with research teams who have that level of expertise. The other thing I get asked if you're looking at taking something off the market, choosing something existing rather than building it yourself, is how do you find it? Where do you find it? Basically, there's unfortunately no one single source. There's no curated way out there. One of the things that seems to work pretty well is to browse the app stores, look at the details that are published, look at comments, look at star ratings, use very specific terms to narrow your selections, and then look at the descriptions. You can also look for new release news, health IT news, venture capital companies will do announcements. This is where getting really, really familiar with complex Google searching can be very helpful. So you can search for the clinical area of interest plus mobile health or plus digital health or plus app, something along those lines, to look for top 10 lists. Things along those lines will help you find some of the existing solutions that are out there. You can also engage with your community of researchers. Engage with me. I will help you find it if it's out there. And engage with groups. So here in Colorado, there's a group called mHealth, which is a convening of it's well over 200 digital health entrepreneurial companies here in Colorado working in different areas, many of whom are very interested in doing pilot projects or in partnering with researchers. I know that we're running low on time, so I'm going to go fairly quickly through the last bit of this because I want to give people time for some questions. So I'm just going to highlight some of these considerations because I don't want people's eyes to glaze over. You want to consider the platform that you're operating on. Is it something that you want to have work on a phone? If it's something you want to have work on a mobile phone, is it an Android phone or is it an iPhone or is it something else? Are there any carrier-specific limitations? For example, something that works well on Verizon might not work the same way on AT&T, depending on the kind of information that you're exchanging. Native versus responsive or versus hybrid design. This is basically, are you building something that's custom tailored to the platform on which it runs, or are you building something which works a little bit more broadly across them, but which might not take advantage of all of the custom tweaks that each platform can do? Each platform has a slightly different code base, has a slightly different set of requirements. The app stores have different policies for anything if you're going to be releasing it within there. You want to think about server infrastructure, what's going to run the back end of the solution that you're considering, and where is the data being stored? Is it in the solution itself or is it on a server somewhere, and who has access to that? Again, with that question of access and data storage, how is information exchanged? Is it connected to the EHR, or can it be connected to the EHR? Is the data stored in the cloud, or is it stored locally? And then how is the data governed? How are these? This goes back to who owns the data, how is it protected, how is it regulated? I'm going to zip through these really quick. This is the idea of interoperability, which is the idea of free exchange back and forth between systems. There's something called the SMART standard out there. I encourage people to look that up. That is basically a standard for mobile devices, mobile applications, mobile solutions to exchange information in a structured way that can be easily adopted and adapted and imported into the major EHRs out there. All the major vendors are on board with supporting things that are built to SMART standards. Fast healthcare interoperability resources. How many people have heard of Health Level 7 or HL7? That's basically the communications language, the communications protocol that clinical systems use to talk to each other. FHIR, which is what this stands for, is the next generation of that language, of that protocol. And it is designed specifically to support mobile information exchange in ways that are built in rather than having to build something new every single time. I mentioned FDA legislation and regulation early on. I mentioned HIPAA early on. I want to bring this up here and point it out as you're considering the work that you're looking to do and the solutions that you're looking to integrate and what answers you're trying to, what questions you're trying to answer and what things you're trying to accomplish. The FDA regulates anything that influences medical decision making. So if it's a medical device data system, if it influences directly or has the potential to influence some sort of medical outcome, the FDA is interested in it. If it's not performing a medical device function, if it's more of a wellness thing, or if it's providing information that doesn't necessarily lead directly to a change in clinical treatment or medical outcomes, they are not interested in regulating it. They don't want to regulate anything that's interactive with an EHR, for example. That's handled by the EHR vendors and their standards. They don't want to regulate anything that has to do with self-management, information self-management, information tracking and organization. So when you're thinking about your solutions and whether or not the FDA needs to be involved, these are all key. HIPAA, the really key thing, we're all familiar with HIPAA, so the really key thing here to highlight is this last point. Under the HIPAA Privacy and Security Omnibus Rule, most recently updated in 2013, you cannot have end-to-end electronic information exchange without a person in the mix somewhere pressing a button that's unencrypted. If it's automatic, it has to be encrypted under HIPAA. And that is important when taking into account like text message-based interventions, things like that. Anything that's going to provide that sort of information exchange. If it's automatic and it's held to HIPAA standards, it has to be encrypted. And I've seen a lot of really good projects trying to get off the ground die right there because of that particular requirement. The second it becomes automated is where it has to be encrypted. Telephone Consumer Protection Act and CAN spam, these are the two laws that are supposed to prevent us from getting spam calls and spam texts on our phones, things like that. The reason I put this up here is because they have determined that it does apply to mobile and digital health solutions as well. So if you have things that are message-based in your solutions, these laws apply. So you need to think about whether or not you have permission to send that sort of information. In research projects, generally you do because you're getting consent. But for larger scale studies that might be more observational or more pragmatic, you need to think about, is it going to be opt-in or opt-out and consent-wise? And if it's opt-out, is it something that you have permission to do under a treatment relationship or something similar? Intellectual property, very high level run through here. You want to think through patent versus copyright. You can't patent code, but you can copyright it. I'm not a lawyer. I never wanted to be a lawyer. By the time I finished studying mobile and digital health, I became a lot more familiar with the law than I ever wanted to be. I will never understand patent law, but we do have people here on campus who can help with that. CU Innovations can help advise on questions of intellectual property. They can advise on whether or not something needs to be licensed. Licensing covers the use and distribution. Copyright protects the content. So like copyright will protect the code or would protect the content of a messaging library. Licensing would protect how people might use it and whether or not they would use it identical to the way you designed it or if they were able to make any changes. And then trademarks, this is if you have a logo or something like that on any of your products, anything that's a branding. And then just the final thing to touch on here with the idea of intellectual property is that this is shifting very quickly. There are these concepts of things that are called patent trolls and patent aggregators out there, and that's because there's so much potential money in this field that people will tend to try to steal the idea by being if they hear about it and it's not protected in some way, by being the first to file versus the first to invent. It doesn't matter if they invented it or not. If they're the first one to file it with the official government office, they may have some rights over that. Again, this is where I encourage you to, if you believe you have something that needs to be protected, that you're building something new and needs to be protected, talk to CU Innovations, talk to a patent lawyer, talk to me, I'll help you find these people. And also check with your employing organization early. because they may have a stake in intellectual property too that you're doing on their time as well. I've seen some people have some unpleasant surprises in those regards too, where they thought they owned the product entirely and did not. Don't be those people. Don't have that happen to you. Just talk to people early and that will help. So I'm going to stop there. I'm going to put this up for upcoming sessions. We still have a few minutes. I know I've given a lot of information all at once. This is really an introductory info dump. And so I do encourage you to come and contact me after. But before, does anybody have any questions? I've either overwhelmed you or put you all to sleep. Okay. All right. We have our next Accords Child Health Outcomes Research Series session is coming up on the 22nd, and that will be Dr. Jody Holtrup giving an introduction to D&I, Dissemination and Implementation Research. That should be a really good talk. I encourage people to come to that if they can. It should be really, really valuable. And if you're interested in mobile and digital health research, I was encouraging people strongly to think about that implementation science component. These are some of the concepts that you'll want to be considering. So I really do encourage you to come to that. If you have questions later, please, please, please reach out to me. I am here to help. You can reach me by phone or email at any time, and I will be happy to talk with you. That's it. Thank you.